Okay, so let's have a look at the Leaving Certificate Higher Level Maths Paper 2 for 2019, question 9. So this involves a triangular patch of ground, SGH. So we have SGH here, so we have this triangle here. SH is 58, GH is 30, and the angle in between them is 68 degrees. The circle is a helicopter pad, and the circle is actually an incircle of the triangle SGH. So the center here is P, which means really when you understand that this is an incircle, you should realize that if you join P to S, that line segment divides this angle here in half, and same here, if you join P to G, it bisects this angle here. If you join P to H, it'll bisect this angle here. So that might be useful later on. Okay, so find SG. So we got to find the distance SG here. So what you got to realize here is you got this big non-right angle triangle here. You have two sides and an enclosed angle, so that should indicate that you're going to need to use the cosine rule to find this side here. So let's do that. So we're going to look for the side SG. So it's that side squared is equal to 30 squared plus 58 squared minus twice those two sides multiplied, 30 times 58, and then cosine of the angle in between them, which is 68 degrees. So you got to work this out then. SG squared then is equal to, when you do these two first, I'm just going to do these two first here, that'll give you 4264. Now I'm going to do just these ones here. That will give you 3480. This is cosine 68 degrees, and when you work that out, SG squared, you get 2960.3690 Okay, so all we've got to do now is just square root both sides. So I'm going to square root the left hand side. That'll give me SG, which is what I'm looking for. Square root this side here and round to one decimal place. So you got to round it to one decimal place. That will give me 54.4 meters, and that's to one decimal place. 54.4. So let me just write that in here. So that's 54.4 meters here. Okay, second part then, part B, find the angle HSG. Give your answer in degrees correct to two decimal places. So HSG is this angle here. So you can do this two ways actually. You can use the cosine rule again because we have three sides, or what I'm going to do is use the sine rule. So I'm going to take the sine of this angle that we're looking for over 30 is equal to sine 68 over 54.4. Okay, so it's going to be sine of the angle HSG divided by the side opposite, which is 30, is equal to the sine of 68 degrees divided by the side opposite, which is 54.4. So you just got to manipulate this a bit and get sine of the angle HSG on its own there. That'll give you 30 times sine 68 degrees, and then divide by 54.4. Now the sine of the angle HSG, then when you work all of this out here, you should get 0.511 3146 257. And finally then, to find the angle, the actual angle HSG, you just got to get the sine inverse. So on your calculator it's just sine inverse. It's this function here of this number here on your right. You've also got to round this, your answer, to two decimal places. So you should get 30.75 degrees, and that's to two decimal places. 30.75. So 30.75 is this angle here, 30.75 degrees. That's that angle there. Okay, so let's have a look at the next one then. Find the area of the triangle SGH. Give your answer in meters squared, correct to 2 decimal places. So now we're going to look at finding the area of this triangle here, SGH. Now again, you should notice here that we have two sides and we have an enclosed angle. So that should indicate when we're talking about area, you can use half AB sine C. So it's half this side times this side sine of the enclosed angle. So that's what I'm going to use here. So the area of the triangle SGH is going to be equal to half AB sine C. So in our particular case, we've got half times A, which is 30, B, which is 58, and then we've got sine of the angle in between them, which is 68 degrees. So all you've got to do is just work that out. And do we need to round this? Yes, we need to round it to 2 decimal places. So you should get 806.65. And now we're talking meters squared, and this is again to 2 decimal places, 806.65 meters squared. Next part then is we've got to find the area of the triangle HSP in terms of OR, where OR is the radius of the helicopter pad. So HSP then, HSP is going to be, this is HSP. So this triangle here we're going to find the area of. So it's going to be this triangle here. Now what you should notice here is that you have this line here, which is a tangent to the circle. You have a radius meeting the tangent to the circle, so that means it meets it at right angles. So in other words, this angle here is a right angle. These two angles here are right angles. So therefore OR here is actually the perpendicular height of this triangle, given that 58 is the base. So all I've got to do here is just straightforward half the base times the height. So it's half 58 times OR. Half 58 times OR. That's all I'm going to do in this section. So let's do that. So the area of our triangle HSP is just going to be the half the base times the height. Half the base times the height. So it's going to be half of 58 times the height in our case, which is just OR. So our answer in terms of OR is 29 OR, and that's meters. So that's it. So next part then, show that the area of the triangle SGH in terms of OR can be written as 71.2 OR meters squared. So really all we're going to do here is exactly the same as we did in part D1 here. We're just going to do it 2 more times. So if you come up here, you'll see we can do exactly the same. So let me just draw these triangles. So you can draw this triangle here, and you can see then that the radius from here to here is going to be the perpendicular height of this triangle here. We can also do the same here. This radius here, this is OR here, remember, this is also OR here. So this radius here is the perpendicular height of this triangle. This radius here is the perpendicular height of this triangle. So all you've got to do is do half the base times the height, do half the base times the height here, add these 3 areas up, and we should, according to the question, get 71.2 OR. So hopefully we will. So let's do that. Okay, so we already have 29 OR here, so that's a start anyway. So let's do the area of the triangle SHP. This is the area of the triangle SHP, so that's up here. Let's do the area of the triangle. What were the letters again? Let me just have a look up here. So we have GPS. We'll do GPS first. Okay, so the area of the triangle GPS. So again, it's just half the base times the height. So it's going to be half times, now the base in that case is 54.4, and the height then is or. So when you do that, you get 27.2 or 27.2 or meters squared. Now we're going to do the area of the triangle. What's that one called? GSH. Again, that's just going to be half the base times the height, so it's going to be half times, in this case it's going to be 30 was the base and the height was or, so this will give me 15 or meters squared. So look, I have this area here, I have this area here, and I have this area here. So all I got to do is add those three. So that means then that the area of the triangle SGH is equal to 29 or plus 27.2 or plus 15 or, and when you add those three up you do get 71.2 or meters squared. So we do get what they actually asked us to find, so that's part 2 done. Let's do part 3 then. In this particular case we have to find or, find out what or is. Give your answer in meters correct to one decimal place. Now we know that the area of the triangle SGH is equal to 71.2 or, and we also know from previous part C actually that we found the area by doing half AB sine C, and it was 806.65. So all we've got to do here is solve for or, so just divide across by 71.2 and you get 11.3 meters, and that's to one decimal place. That's it, fairly straightforward. Okay, so almost there. We've got part E now. Okay, so we have this vertical pole here, and it's at S and it goes up to T. It's vertical, so we have a right angle here, and there's something joining P to T, let's say. So we have this triangle here, PST. The angle of elevation of the top of the pole from the point P is 14. So in other words, this angle here is 14 degrees. This angle here is 14 degrees. We've got to find the height of the pole, so we've got to work out what this height is here. Now, I'm going to do this by looking at this triangle here first. Oops, I'll just go back a little bit on that. So I'm going to join P to here, to HS, and this is going to be a right angle here. This is a right angle here. So I'm going to look at that triangle there, and let's call it M. Let's call that point there M, for example. So if I draw that triangle, it should look like this. This triangle is flat on the ground, I remember. So this is M here, this is P here, this is S here. Now I know that this distance here is 11.3 meters. I just worked that out. Now this angle here, remember what I said at the very beginning about this circle here being an incircle, which means if you join P to S, you're bisecting this angle GSH. Now we know that that angle GSH from the very beginning, we worked it out, GSH was 30.75. So that was 30.75. That would mean that means then that the angle, the size of the angle PSM, it's going to be half of this here. So half of that is 15.375. So So in other words, this angle here is 15.375 degrees. This angle here. Okay, now what I want to do here is work out what PS is, this distance along here down the middle. Because if I have that side here, I have one of the sides of this triangle here, this vertical triangle. So I'm going to work out what PS is. So in order to do that, I'm going to use sine of the angle PSM. I'm going to use sine of the angle PSM. So let's work through that then. So I'm going to work out sine of 15.375. That's going to be equal to 11.3 over PS. Okay, so let's just work through that then. Now let's see, that would give me PS times sine 15.375 is equal to 11.3, or PS is equal to 11.3 divided by sine 15.375. Okay. So let me just work that out quickly on my calculator here. So we have the size of PS here is equal to 11.3 divided by the sine of the angle 15.375, and we get 42. So we're going to get 42.6197 So P to S is 42.619 and so on meters. Okay, so now I'm going to look at this vertical triangle here, this triangle here. So I'll just draw that first of all. So we have a triangle that looks like this. Right angle here. We know that this is 14 degrees. We were told that in the question. We've worked out this is P here, this is S, and this is T up here. Now we've just worked out that this side here, PS, is 42.61972.894 meters. We probably don't need all those decimal places, but we'll use them anyway. We've got to find, the question was find the height of the pole to one decimal place. So the height of the pole is this here. We got to work this out here. So in this particular case, we want to work out TS, which is the opposite. We have the adjacent, so we're going to use tan. So I'm going to say tan 14 degrees is equal to TS, the size TS, over 42.61972.894. So just multiply across 42.61972.894 times tan 14, and that gives me the distance TS. So again, I haven't worked this out previously, so I'm just going to quickly do this on my calculator. So let's see, we've got TS here. So let's see, we have 42.61972.894. we got to multiply that by the tan of 14 degrees, and we get 10.62. Now let me just see, how many decimal places do we need? One decimal place. Okay, so we finally end up with the distance TS then is just 10.6 meters. Okay, and that's it for this particular question.